One of the most critical parts to a design these days is security. Unfortunately, it's a challenge that a lot of developers aren't really addressing well. So, Winston, at QNX, you guys have done a little bit of research and some surveys on this. Could you tell us what are the results overall?
Yeah, so the latest research has revealed some critical challenges facing software engineers in industries like automotive, robotics, medical, even industrial. So as systems grow increasingly more complex, engineers are often under immense pressure to deliver their products quicker and often with fewer resources. So this environment has affected many to make trade-offs, especially with safety and security, just to meet deadlines. So with systems now comprising of millions of lines of code, ensuring compliance with safety standards like ISO 26262, IEC 62304, or even IEC 61508, or security standards like ISO 21434 for automotive or 62443 for industrial. It's a huge and monumental task for these engineers. So engineers aren't just trying to build reliable systems, but they're also trying to navigate all these stringent certifications and tight schedules. So based on these pain points, this is kind of why we're seeing customers are open to changing OSs and where we're seeing companies seek out proprietary solutions to help bridge the gap like those offered by QNX.
What are some of the problems that people are causing or not necessarily addressing at this point uh, that the survey results reflect?
So as I mentioned before, there's a lot of just it's really difficult to follow these standards. So if you look at the security trends all over the world, right, cybersecurity governance has seen a big shift recently. So last year we saw the FDA introduce new cybersecurity requirements for medical devices. This is an added functionality to pre-certification to get the approvals to get the standings with FDA. Now, this year, we see the EU Cyber Resilience Act has taken things even further by requiring connected products across all sectors to meet higher security standards. So
Mhm.
what's interesting is that a lot of these regulations are pushing manufacturers to adopt security by design approaches, making cybersecurity more of a core part of the product development. So it's not just about compliance. It's not just about putting security after as an afterthought. It's about embedding security into the actual design and architecture of the product throughout the entire life cycle of that device or system.
But when we're talking about security, what are some of the more specific things that people need to design into the applications? Is it secure communications? Is it authentication? How do these things come together? Because the next questions could be, how does that affect the operating system? So let's start with the first part.
Yeah, so when you're looking at cybersecurity, you're looking at from the bottom up. So you're looking at security from the hardware all the way up to the OS when you're booting it up. So which is what we call secure boot, all the way up to the application layer. So your first line of defense is going to be your OS, right? So when you're talking about security, we're talking about making sure that your architecture is there, designed with minimal attack surfaces, minimal lines of code, so that you're making sure that when you have malicious actors trying to hack into your system, there's less opportunities for them to get into your system so that it operating as intended and as function.
When we're trying to put these pieces together, how does the operating system come into play? Is this a matter of making sure you just have a secure operating system, or is there more to it?
With QNX, what we're looking at is we've designed our OS with a microkernel architecture that provides a secure and reliable platform. It basically what that means is it isolates critical processes and prevents vulnerabilities from escalating within features like temporal and spatial isolation. So it's basically a fault-tolerant design that ensures system failures are contained to the affected components, allowing critical processes to continue operating uninterrupted, isolating drivers, applications, and core OS services to their respective or separated memory spaces, and ensuring that the architecture is able to swiftly fault recover from these things that are escalating, these failures to escalate. So
Mhm.
essentially, basically what you want to do is you want to, if a driver's failure or someone hacked into it and it's not behaving as intended, you're able to isolate that component without infecting the entire system and shutting it down.
What partitioning capabilities does QNX have in terms of, say, virtual memory support, hypervisor support? How are those pieces coming together with respect to security?
Yeah, so with the QNX OS, our RTOS is built on a microkernel architecture. So the kernel space is actually reduced to a very minimal operating environment. So the code base for the kernel is very limited, and then everything else is respectively in the user space. So by design, it's already built as a fault-tolerant mechanism. We also have our hypervisor, which allows for virtualization. So built on the microkernel architecture, we also have virtualization support, which allows you to run safe and secure processes in the host, while also running on the guest OS using applications like Yocto Linux or Android.
So where do you see security headed in the future, especially with respect to developers? Is this something that's going to be easier for them to do, or just something that they're going to have to contend with now?
I think it's much like safety. Security is going to be have to baked into every process of the development lifecycle. So what we've done is we've taken a three-pillar approach. So our organization, we build a culture that lives and breathes and the understanding and importance of cybersecurity, which allows us to ensure that our products are secure and designed with cybersecurity at the core. And then we also foster an ecosystem of partners that extends and enhances QNX cybersecurity capabilities. So it's very difficult for one organization to do everything under the sun, which
Mhm.
is why we adopted this three-pronged approach to cybersecurity.
Is that an approach that application developers should be taking into account as well? Because obviously, once they start with your secure base, the applications they put on top of it are also something that needs to be secure as well.
Yeah, so if you look at the automotive cybersecurity standard, ISO 21434, it's an international standard that addresses cybersecurity risk in the design and development of automotive systems. So to achieve this certification, it requires that you adhere to the highest level of cybersecurity protocols and practices,
Mhm.
which encompasses these three pillars. So you're looking at from the entire lifecycle of automotive products from initial concept all the way up to decommissioning. So even though our operating system might be secure, right? Your organization has to also adopt the culture of cybersecurity so that when they're building their applications, they're building it in a secure manner, same way as they're building it in a safe manner for the functional safety applications.
Great. Well, thanks very much for filling us in where things are heading with respect to security.